All right, let's just jump right in because today we're tackling a problem that is truly out of this world. We're talking about waste management. But no, I'm not talking about your blue bin at the curb. We're talking about what it's going to take to build a sustainable human presence on the moon. Yeah, that's right. It all starts with one huge, surprisingly complex problem: trash. Dealing with waste on the moon, it's a totally different ballgame than here on Earth. This is a mission-critical problem that absolutely needs a high-tech solution.
So think about this for a second. How are you supposed to recycle when your nearest plant is, just about 240,000 miles away, back on an entirely different planet? That right there, that's the core dilemma for any future lunar mission.
And the difference between Earth and the moon here is, well, it's just wild. Here on Earth, right, we've got our neat little categories: paper, plastic, glass. But on the moon, forget it. You're dealing with one single hazardous, totally unsorted mess. A mix of everything it takes to just stay alive. And yeah, this is not your leftover pizza boxes and soda cans. We're talking about really specific kind of gnarly stuff. You've got gear caked in that super abrasive lunar dust, the regolith. You have broken tools, scraps from 3D printing, weird foils and polymers, and that's not even mentioning the wiring, chemical goop from coolants, and used up life support filters. It is a seriously complex and dangerous cocktail of waste. Okay, so how in the world do you solve a problem like moon trash? Well, every good story needs a hero, right? And this is where we meet ours. Let's introduce the proposed solution, the Living GemCycle. So the Living GemCycle Unit, or LGU for short, is basically this super smart modular recycling system. Its whole job, its entire reason for being, is to take that gnarly mix of waste and turn it into something valuable, something you can actually use again. And the best part? It all happens right there, inside the habitat. And the way it's designed is actually kind of brilliant. Think of it like a body. First, you've got the input hopper. That's the mouth. It just eats all the mixed up waste. Then there's the processing core. This is the stomach, right? The heart of the machine, where everything gets shredded and sterilized. The AI controller, well, that's the brain, making all the smart calls. And finally, you have the output modules, which create all the brand new, useful stuff. But here's the thing. The real magic, the piece that makes this whole thing possible in such a crazy environment, is its smart sorting. Yeah, the secret sauce is absolutely the AI. You see, unlike our systems here on Earth, where we have to do all the sorting, the LGU's artificial intelligence is basically its brain and its eyes. It just looks at every piece of waste and automatically figures out what to do with it. No human intervention needed. And this all happens in one slick automated process. So, step 1, it identifies everything using fancy sensors. Step 2, it separates out the metals and that nasty lunar dust using magnets and static. Step 3, it pre-treats whatever needs it. Maybe it zaps some biowaste to sterilize it or shreds a bigger part. And finally, step 4, all the sorted, prepped stuff gets sent to the right place for final processing. Boom, boom, boom. Okay, so that brings us to the big payoff. After all that smart sorting and processing, what do you actually get? Now this is where it gets really, really cool. It's like the ultimate transformation. So you put in all that junk we mentioned before, the broken parts, the used up filters, all of it, and what comes out the other end? Actual usable resources. I'm talking filament for your 3D printer so you can make new tools on the spot, new panels for building things, materials for repairs. It basically closes the loop. Nothing goes to waste, even when you're 250,000 miles from home. And get this, the whole machine is designed to weigh less than 50 kilograms. Now, you have to remember, in spaceflight, every single gram costs a fortune to launch. So having a system this powerful that's also this light, it's an absolute game changer. And it's not just light, it's tiny. It takes up less than 1 cubic meter of space. I mean, think about it. Inside a lunar habitat, space is at an absolute premium. Every inch is precious real estate. So a little powerhouse like this that can just tuck into a corner, that's huge. But maybe the most incredible stat of all, because it's so automated, it's designed to take up less than 1 hour of an astronaut's time per week. I mean, an astronaut's time is maybe the most valuable resource on the entire mission. You want them doing science, exploring, not sorting garbage. So when you put all these pieces together, lightweight, compact, automated, you start to see that the LGU isn't just about keeping the place tidy. No, this is a foundational piece of the puzzle for making a long-term, sustainable life on the moon actually possible.
Let's look at how it lines up perfectly with what NASA wants to do. First, it creates a true closed-loop system. It stops contamination from that regolith and other biohazards. It makes sure all the dangerous stuff is handled safely. It even pulls out valuable elements like hydrogen and carbon. And, here's the big one, it cuts down massively on having to ship stuff from Earth. I mean, why would you launch a new wrench when you can just print one using yesterday's garbage? So you see, in the end, this isn't really a story about waste management at all. It's a story about survival. It's about what it takes to be truly self-sufficient when you are so far from home. You know, the founder of InterGemm, the company behind this idea, Basiru Gumban, he said it perfectly. He said, every module in the LGU was built to think, adapt, and serve, because lunar waste deserves lunar intelligence. I just love that. It's about creating a solution that's just as smart as the problem is hard.
And that really leaves us with a huge question to chew on, doesn't it? We've just talked about reinventing the recycling plant for the moon. So what's next? What other everyday things we take for granted here on Earth will we have to completely reinvent for us to really live and thrive out there among the stars?